Welcome to the session of measure of central tendency. Now, before we move on, we must understand what is statistics. Statistics is simply collection, presentation, analysis, and interpretation of data. So, statistics mainly involves around the data. And the main objective of the statistics is to collect the raw data and convert it into information. Now, data is something which is raw, and information is which is processed or organized data. Now, simply if you collect the age of 10 students and just write it down, you are not able to make out anything from it. But if you just simply write them in ascending or descending order, you can understand who is the eldest, who is the youngest, and so on. So basically, statistics is converting the data into information. Now there's a small activity which I just want to share here. Now what is statistics? Statistics mean only numbers with no meaning. Now this statement is false. It is not the numbers, it has some meaning attached to it. Another, calculating percentage is mathematics or statistics. This is mathematics because statistics mainly is around mean, median, mode, standard deviation, and other. All businesses are certain or uncertain. There is always an uncertainty in the business. So the businesses are uncertain. It's just to understand what exactly you do, what all activities you can do with the statistics. Now, next is there are two branches of statistics. One is descriptive statistics. Now, descriptive statistics, we cover measures of central tendency, that is mean, median, mode, and measures of dispersion, standard deviation, that is range, standard deviation, variance, coefficient of variance. Fine. And inferential statistics is all about finding a result or coming to a conclusions, and the tools are estimation, point estimation and interval estimation, hypothesis testing, analyzing the relationship. So basically what we do in inferential, we come to a conclusion of your analysis. In descriptive, we do the analysis. Fine. But when we say dispersion is measures the scatterness of data, whereas central tendency measures the middle point of the data. Fine. We are going to take up this in detail in the subsequent slides. Now, presentation of data. Now there are various modes how you can present your data. You can just see your Excel sheet, there is a chart button, and you will come across various methods of presentation of data. Commonly used is bar graph, histogram, pie chart, scatter diagram, and graph, line graph. Right? So there are many others. Different categories of pie charts are also there. So presenting a data is very important. Sometimes reading a paragraph is very difficult to understand. If we just make a simple bar graph, we understand it better. So presentation of data helps in apprehension of the data. Okay, so let's move on further on this. Let's now see this, go into detail a little bit more of descriptive statistics. Now, as I told you, descriptive statistics has covers measures of central tendency. Now what is measure of central tendency? It shows a tendency of some central value around which the data tends to cluster. So middle value around which the most of the value of the data is clustered. Right? Now there are various measures of central tendency: mean, median, and mode. Commonly are mean, median, and mode. Now mean, all three are called the averages. All measures of central tendency are called the averages. Mean is the mathematical average, median is the positional average, and mode is the most frequent or most common average. Fine. So now positional averages, may we have median, median is actually is positional average, but mode we generally call it in position, but it's actually the most common value of the data set is called mode. Then there are other measures of positional as quartiles, deciles, percentiles. We'll take this separately in the subsequent slide. Let's move on further. Now, when we talk about mean in statistics, we are only concerned with the arithmetic mean. There are three types of means: arithmetic, geometric, and harmonic. But in statistics, when we say mean, it means we are talking about the arithmetic mean. Simply, what is arithmetic mean? It is the sum of all the observation divided by number of observation. So if there are, we know the age of 5 students, we add the ages of all the 5 students and divide it by 5, we get the mean, right? Now in Excel you can simply calculate using an average function. The syntax is shown here on the screen. Equal to average and array the range of values where the values are there, right? Now there are one or two very important properties of mean which you must understand. First of all, mean is dependent on change of origin. Now when I say dependent of change of origin, means if I add or subtract any value from each observation of the data, then the mean is all new mean is also increased by same value. Suppose there are 5 values, and if I add 3 to each of these values, then suppose original 5 values the mean was 25, and if I add 3 to each of the 5 observation, the new mean will be 28. It will be increased by. Similarly, if it decrease 3, the new mean will also be decreased by. So that is called dependent on change of origin. Fine. Again, it is also dependent on change of scale. What do you mean by this? Change of scale means if I multiply each observation by 3, then the new mean is 3 times the old mean. If I divide each observation by 3, then the new mean is also divided by old mean divided by 3. Right? So this is what these are two important. Another very important property of mean is that sum of deviations around arithmetic mean is always 0. What do you mean by sum of deviation? If from each observation I subtract their mean and then I add all the values, then the sum will always be 0. This is you can use as a cross check whether your answer is correct or not. You can always check it like this: subtract the mean which you have found from each observation and add all these deviations, the sum will always be 0. These are very important properties which you must understand. Okay, let's move further. Now median is, it appears in the middle of an ordered sequence. Now whenever you have to calculate median, step 1 is to arrange the observations either in the ascending order or in the descending order. Fine. Suppose we arrange them in ascending order, and if there are odd number of observations, then the value of median, the position of median will be, if there are 5 observations, 5 plus 1 divided by 2, that is the third item in the sequence, ascending or descending, will be the value of median. Whereas if you have even number of observations, now in that case the value of median will be the size of the n by 2th item plus n by 2th plus 1 item divided by 2. Suppose there are 6 observations. Fine. So 6 by 2 is 3. So third item in the series plus the 4th item in the series, n by 2 plus 1. And if you take the mean of those two, you get the median in that case. So finding median for even and odd number of observation is different, and this is how you have to do. So median is basically the middle point of the data. So if there are 21 observation, this median, there will be exactly the equal number of observation less than the median value and equal number of observation more than the median value, because median is exactly in the center. Okay, so let's move on further. Now mode, as said, is number which occurs most frequently. Now Excel function is mode equal to arrow, mode equal to mode, the range of values, and you get the mode of the value. Now there may be more than one mode also, but when you calculate in Excel you just get the one value only. There is a relationship between the mean, median, all the 3 measures of tendency, and it is like this: mode is equal to 3 times median minus 2 times mean. So this will give you approximation of mode. Fine. So this doesn't give you the exact value, but this is an asymmetric relationship, empirical relationship between the 3 measures of tendency, and it's widely used also for that. So moving on further, coming to the, like, median is the middle point of the, divide the data set into 2 parts. Similarly, quartiles divide the data set into 4 parts. Quarter means 4 parts. Data into 4 using 3 quartiles. Q1 is the first quartile, first 25% of the value. Q2 is same as median, first 50% of the value, and Q3 is the first 75% of the value. And and this is how you calculate the value of Q1, Q2, and Q1. If there is if we have to calculate q1, it will be n plus 1 by fourth item of that data set will be the value of first quartile, and q2 is same as median. q3 will be 3 into n plus 1 by fourth item. Right? So this is how we calculate. Basically these are very important when you have to do analysis and understand where is the bulk of the values lying. Fine. So we use this quartiles, percentiles, median is a very important tool used in statistics for this purpose. Let's move on further. There's a small activity. Now as I told you, sum of deviation around the mean is just discussed 0. If each observation is doubled, then the new mean is doubled because it is dependent on change of origin. Mean is independent of change of origin. No, it is dependent of change. So it's false. Median is the positional average. Yes, it is true. Median is dependent on change of scale. Yeah, mean is dependent on the change of scale. Yes, it's true. As I told you, when you multiply each observation by 4, then new mean is 4 times the previous mean. Moving on further on this. Now quartile, this is the so you have straight function in Excel where you can quartile, you can find out the quartiles. Fine. In journal, we have generalized the formula for quartile. Qi is equals to I into n plus 1 by fourth item. Now if the first quartile I is 1, second quartile I is 2, third quartile I is 3, and so on. This is a generalized form. Okay. Now as the name suggests, percentile means percent, that is out of 100. Percentiles are divided the data into 100 equal parts. So we have P1 to P99, they are total 99 percentiles, and this is the general formula for calculating the percentiles. Pi I into n plus 1 by 100th item. Now this is I is what? First percentile it is 1, second percentile is 2, third percentile it is, and so on till the 99th percentile it will be 99. This is how you calculate the percentile of the data set. So there is a same direct Excel function also, percentile array the range of values, and then you write in percentile, you will get the values of percentile. Right? So this is how you use the Excel functions also. So this covers basically the 3 measures of center tendency. Our next video which we will be sharing will be on the measures of dispersion. I hope you have understood this. Thank you so much for the patience. Thank you so much.